Good day, guys. Welcome to the Wonderverse. I am the greatest teacher there is, the greatest teacher there was, the greatest teacher there ever will be, the greatest teacher of all time, aka Marshall D. Teach. And today we are going to be handling longitude and latitude, right? Okay. Now, firstly, when you hear longitude and latitude, what do you understand? What do you understand by longitude and latitude? I'm sure you must have heard it before. It's more like coordinates, a position on a map or a position on Earth. You understand? Okay. Now, why was this topic founded in the first place? You might be wondering, what are we using this topic to do? Let me inform you. This topic was formed because people wanted to understand, or people wanted to know, what is the distance between this place and this place on the Earth's surface. If you're measuring the distance in your compound, you can simply use a tape. But what if you're measuring somewhere from America to Nigeria? Do you want to use tape? You cannot. You can't use a tape. So this time around, we decided we have to manipulate and find a way to find the distance between two positions far apart from each other. Of course, you can't stretch a tape across the sea, but we'll find a way. Now, this is it. I want you to imagine this. This is the Earth. Look at this. This is the Earth. And now, this is a position on the Earth. Let's say Africa is somewhere here. Okay, now I want to find a place. Let me say, I want to find a place here. How do I find it? How do I find the distance between this place and this place, point A and point B? That is what longitude and latitude teaches you. Now, the Earth is a geoid. The Earth is not exactly a sphere, but a geoid is more like a rougher type of sphere. A geoid is a rougher type of sphere, an irregular sphere. So basically, in math, we try to make everything easy by then assuming that the Earth is a sphere by taking the average radius of the Earth across each part of the geoid, right? Please, if you're a flat earther, leave this video. We are about to enter into some theory stuff that explains how this thing works. Basically, how we got the radius of the Earth. So if you do not think that the Earth is spherical, you think the Earth is flat, please leave this video. And we are about to enter some theoretical stuff. So if you want to just go straight to the calculation stuff, you can skip to the end of the video. I know you're here just because you want to pass your exam. For those that are watching this because of the exam is tomorrow or next week, I know you guys. I'll put the time tag. Now, this is the shape of a geoid. Don't worry, you're going to see it in the video. I'm going to put it there. Now, people wanted to know what is the radius of the Earth, because if you want to get this distance, let's say the center of the Earth is somewhere here. And this is the center of the Earth. Just imagine it like a donut, the center of that donut. This is the center of the Earth. So now, if you realize something, check this with me. Look at this. If this is the center of the Earth, and you want to find the distance between here and here, all you have to do is to connect like this and connect like this. Now you're going to have something like this. If I move this to the side, I'm going to have something like this. This is Earth on a 2D view. I'm having something like this. So now I can see this is the center of the Earth. This is the center of the Earth. And this is that A and B, right? So what is this place? These are the radius of the Earth. So are you seeing, finding the distance between two places on the surface of the Earth is basically like finding the length of an arc. Do you get it? Finding the distance between two places on the surface of the Earth is like finding the length of an arc. So what do we remember is the formula for the length of an arc of a circle? We'll get back there. What did you say is the answer?
Theta all over 360 times 2 pi r.
Yes, she said theta over 360 times 2 pi r, which is correct. That is how we are going to be finding distances. But for now, we are going to get back there. Now, I told you can skip to the end. Sorry, you can skip to the time tag that I give you if you want to go into the calculation part. But let me explain something to you. Now, someone wanted to know what is the radius of the earth, because in this video, every time we want to solve for the radius, solve for anything, calculation, distance, the radius of the earth we are going to be using is this. We say the radius of the earth is 6,400 kilometers. The radius of the earth is 6,400 kilometers. How did we know? How did we know? How did we know that from the center of the earth to any point on its circumference, from the center of the earth to any point of its circumference is 6,400 kilometers? How did we know? Now listen. There was this Greece guy, like this guy from Greece, I think from Athens. His name was Episto something. Yes, but this particular guy, he was innovative enough to try and find out what is the radius of the earth I'm standing on. It was not like, since the earth is a sphere, I'll prove to you the earth is a sphere, but in a different video. He was like, since the earth is a sphere, why don't I just use this principle? If I stand at one point of Greece and my friend stands at the other edge of Greece, can't we take the distance between ourselves? Can't we take the distance between ourselves, like the distance between ourselves, like tape, using a tape? And then when we find the distance between ourselves using this formula, if we have the distance between ourselves and we have the angle between ourselves, and we have the angle between ourselves from the center of the earth, that is, my friend is standing here, my friend is standing at A, I'm standing at B. If we have this angle and we find the distance between ourselves, wouldn't that mean all we have to do is find R, and that is basically the radius of the earth? So this guy was very smart. He was very smart, and that is how he cracked it. These things are not far-fetched. This is how humans know what the radius of the earth is. Now, how did he know the angle between him and his friend? It's obviously easy to measure the distance between him and his friends across the town. But how did he know the angle? Now see, around 12 p.m. during their own time, there was a particular place in his city that if you stand directly under the sun, you don't have any shadow. If you stand directly under the sun, you don't have any shadow. But then his friend stood at a particular side of the city and noticed that at the exact same time, 12 p.m., when the guy stood at the center of the city and there was no shadow, he had no shadow, his friend stood at another side of the city and noticed that he had shadow. Therefore, he was at an angle to the sun, right? Since he had a shadow, he measured the angle of that shadow, and that was it. That was the angle between them. So humans are very innovative. Humans are very, very innovative. That is how they cracked it. Now, they did this across different parts of the world, taking angle from where there is shadow, taking another angle from where there is no shadow at the exact same time, therefore getting the angles between themselves. And that is how they were applying it to this formula. They know the distance between themselves, they get the angles between themselves, and that is how they proved that on average the radius of the earth was 6,400 kilometers. Okay, so I was interrupted, so we have to continue from where we stopped. Now we are about to look at the earth, dissect it, and understand how this topic works. Look at this. Now, this is planet Earth. This is the center of planet Earth. If it's too hard for you to imagine it as Earth, you can just imagine it like an orange, right? Now look at this. This is the direct center of the Earth, and it's called the equator. The equator, okay, now you should note this is north, this is south, this is east, and this is west. The equator is the big circle that divides the earth into the northern hemisphere and the southern hemisphere, right? Note that. Note that the equator is the big circle that divides the earth into the northern hemisphere and the southern hemisphere. Now, this is your polar axis. The polar axis is the line that stretches from the north pole to the south pole of the earth. It goes like this. That is your north pole. Now, let me tell you guys about big circles and small circles. Now, see, a big circle is the largest circle you can get from a sphere, or is the widest point, is the widest circle you can get. For example, now, if I draw a circle here around this globe, if I draw a circle around Earth from on top here, it's a small circle. It's a small circle. Most times you get the big circle around here, around the center, around the middle. For example, now, when I was younger, in fact, even now, when my mom is cutting orange for I and my sister, out of respect for the fact that I'm older than her, she will cut the smaller part for her. So that makes it, she's holding the small circle, right? She's holding the small circle. I myself, the big circle is still part of my own orange. Are we following? So that is how it works. Let's move forward. Now, the big circle can, the big circle can basically also go like this, or even like this. It should be at the center. This is it at the center. Or let's say we took it up. The big circle must not necessarily be at the center of the circle. Just know that it is the widest possible circle you can get from that sphere, but it must not necessarily be at the center. For analysis sake, we just assume this term called big circle, so we can be able to dissect the question into pieces. So that's what it's all about. Now let's move forward to the questions part. Okay, good day guys. We are going to be continuing from where we stopped. As you can see, these things we have here, these are positions. These are positions on the earth. A is 15 degrees north, 30 degrees west. That is a position. B is 15 degrees north, 45 degrees east. That is a position. So all these are positions and you have to find them on the earth. So now I'm going to teach you how to do that. Now, there's something you should understand. A longitude is vertical. It's vertical. Latitude is horizontal. This is a longitude. This is a longitude and this is a latitude. Are we following? Okay. So now, you use latitudes to know how far something is up north or down south. Okay, something is south. I use this to measure how south it is. If it's not so south, it will be somewhere here. If it's very north, it will be somewhere here. If it's very close to the north, it will be somewhere here. Right? Okay, east, west. If something is very close to the east, it will be somewhere here. Are we following? So that's how it works basically. So let's start finding these positions. Firstly, we have 15 degrees north, 30 degrees west. So firstly, we are going to draw a polar axis and the equator. So this should be a broken line. Okay, so now 15 degrees north is going to be where? Where exactly is 15 degrees north going to be? Now, there's something you should understand. 15 degrees north means it is far away from north. 90 degrees north is up here. 0 degrees north will be somewhere in the center. 0 degrees north is the same thing as 0 degrees south. So let me say, let's take assumptions. 90 degrees north is here, 75 degrees north will be here, 50 degrees north will be here. Are you getting it? Let me say 15 degrees north will be somewhere here. So let's draw it. This place, the equator is basically 0 degrees north. So now we have that. 30 degrees west is where? Now there's something you should understand as well. The farther away it is from here, that's the longitude. The higher it is, watch. This, if I drew a longitude like this, it will probably be, let me say 10 degrees west. If I went like this, 45 degrees west. If I keep going further away until I get to this place, it will be 90 degrees west, right? So if they say 30 degrees west, 30 degrees west will be somewhere around here. Are we following? So now, where do 30 degrees west and 15 degrees north meet? Where do they meet? They meet here. So this is A. This is A. This is your A. Let's move forward. Now, let's find B. "15 degrees north," again, it's somewhere around here. 45 degrees east. This time around, is somewhere around here. So 45 degrees east will probably be at the center. Are we following? So where do 15 degrees north and 45 degrees east meet? They meet here. So that is your B. That is your B. Simple, right? Let's move forward. "0 degrees and 30 degrees west." So this is basically saying 0 degrees what? Latitude. 0 degrees latitude and 30 degrees west longitude. So we are going to have this. 0 degrees will be at the center of the earth, basically, somewhere around here. And then 30 degrees west is somewhere north, south, east, and west. So 30 degrees west is somewhere here. Somewhere here. If 30 degrees west is somewhere here and the equator is the 0, this is C. This is C. Now, what if we want to find 45 degrees east? 45 degrees east will be at the center of this place, and the equator is still 0, right? So this is D. Are we following? Now, I'm going to post another video where I'm going to combine everything all together. I'm going to combine everything. That is all these positions. I'll show all of them inside one map, inside one globe. So that's it. Okay. Now, I hope you can see it clearly. We are about to head into the calculation part. You're seeing this. We are going to basically create the earth, and then we are going to find all these positions. We are going to find A on the earth, find B, find C, D, E, F. We are going to find all these on the surface of the earth. You should be able to use your longitude and latitude to locate all these on the earth. So now, what are these? These are basically locations. This is a location. This is the location. These are all locations. Let's find them. Now we have to draw an earth. Draw your earth. Okay. Now after drawing your earth, what do you do next? Let's just draw the equator. Always draw the equator. It helps a lot. In fact, it's very necessary. Make sure you always draw the equator. Okay. Mark your center of the earth. This is the center of my earth. That is the center of my earth. Oh, okay. So now, what do you do? When you hear longitude, you can tell it's something that is long, something that is long. When you hear latitude, you can tell it's something that is flat, something that is flat, right? Now, how does this work? We use latitude. We use latitudes. We draw them like this to measure distances from the north and from the south. We use latitude to measure distances from the north and the south. Listen, we use latitude to measure distances from the north and the south. We use latitude to measure distances from the north and the south. Now we use longitude to measure distances from the east and the west. We use longitude to measure distances from the east and the west. Now let's go. Firstly, we say 15 degrees north. 15 degrees north. What does that mean? A is 15 degrees north. We are about to find A now. They said A is 15 degrees north. You have to draw the latitude to show how far it is away from the north. How far is it away from the north? They say it's 15 degrees north, so it is not close to the north. This is 90 degrees north. That's this spot up here. You say, okay, it's 90 degrees north, but 15 degrees north will probably be somewhere around here. It will be this small circle here. This small circle is 15 degrees north. You get? In fact, let me draw it in a better way. Let's say this small circle is 15 degrees north, right? Okay. So now, where is it? They say 30 degrees west. It is 15 degrees north, but it is 30 degrees west. 15 degrees north, but 30 degrees west. Now, north, south, east, and west. Now, come here, come here. Now, draw a longitude. Draw a longitude, a line of longitude. Come here. Stretch it. This is it. Don't forget, draw your polar axis. So it is here. Do we understand? This is A. That is where A is. That is where A is. Label it. This is 15 degrees north. And this line, this longitude, is 30 degrees west. So this latitude is 15 degrees north. This longitude is 30 degrees west, right? So that is where it is located. Okay, so let's find the next position. Let's find the next position. 15 degrees north, 45 degrees east. I told you that latitude is used to find places on the north or the south. Longitudes are used for west or east, right? So now we already have 15 degrees north. We already have the 15 degrees line on the north. We already have the 15 degrees line on the north. You can tell it's at the upper side of the earth. Okay, so now 45 degrees east. 45 degrees is north, south, east. So we go 45 degrees east, somewhere at the center, somewhere at this middle. That is the longitude of 45 degrees east. label it. So where do they meet? They meet here. Now this is our B. That is our B. Our B is 15 degrees north and 45 degrees east. Are we following? Correct. Now our C is 0 degrees. Is 0 degrees on the north and south. It means it's basically at the center of the earth. It's basically somewhere around the center. Somewhere around the center. Now 30 degrees west. 30 degrees west. So okay, we already have the 30 degrees west line, right? We have a 30 degrees west line, right? So this is our C. This is C. It is 0 degrees on the latitude, 0 degrees north and south. So it is basically at the center. Lengthwise, it is basically at the center of the circle. That is, if you slice an orange into two, but horizontally, yes, you slice it into two, it's at that center, somewhere around that center. Then it is at this side, west. Let's move forward. D, 0 degrees again, and then 45 degrees east is basically here. We already have the 45 degrees east line, right? So this is our D. Now our E, 65 degrees south and 0 degrees. Okay, so where is 0 degrees this time around? 0 degrees is going to be somewhere here. Okay, let's hold on. Let's first draw 65 degrees south. This is south, so you go down to draw your 65 degrees south. Right? 65 degrees south. Now 0 degrees east, so it's going to be somewhere here. Sorry, 0 degrees, so it's going to be somewhere here. Are we following? It is here. So this is your E. It's neither towards the west or the east. It's neither towards the west, it's not towards the east as well. So it's just at the center. It's somewhere along this line here. At the center along this line. Okay, now what about F? 65 degrees south, 45 degrees east. We already have our 45 degrees east line. This is our 45 degrees east line. So 65 degrees south and 45 degrees east met here. So this is our F. So that is basically how to find positions. That is how to find your longitude and latitude, or find a position on Earth, on the surface of the Earth. How do you find, using longitude and latitude, how do you find a point? This is how you do it. Now, we are going to learn how to find angular differences. Stay tuned. Okay, so now we are moving into the topic angular difference. So you should understand there are two types of angular difference. Firstly, there is angular difference in the longitude and there is angular difference in the latitude. Now, what are we talking about? The angle between the lines of latitude. That's what is angular difference in latitude. It is the angle between the lines of latitude of two locations measured north or south. It is the angle between two lines of latitude. You know latitude is flat. Let me say there's one latitude at the top of the earth around north. There's another latitude at the bottom of the earth around south. What is the angle between those two latitudes? Right? That is what we are talking about. Now, make sure to write this down. In the longitude, the angle between the lines of longitude of two locations measured east or west. If there are two longitudes, one is at the south, east, west, and the other one is at the east. What is the angle between them? That is what we are talking about. Now, I hope you wrote this down. We are about to move forward so we understand what we are talking about. Let me show you something. Now, look at this. Let me give you an example of what angular difference is. They say the angle between the lines of latitude of two locations measured north or south. Watch this. Let's say there is a location at the north, then there is a location at the south. I already told you we use latitudes to check north or south, then longitudes to check east or west. This is the center of the earth. So what is the angle between up and down? The angle between this latitude and this latitude, this is the center of the earth. This angle, this angle is the angular difference. We are going to sum these angles. That is your angular difference. So let's move forward. Okay, let me show you something. Assuming it's between two lines of longitude, you have something like this. One is here, another is here. This is the polar axis. Then let's draw the equator. So this is one line of longitude. This is another line of longitude, right? So what is the angle? Okay, let me say then we have this place here. This is the latitude. What is the angle between here and here? Is the angular difference. You have something like this. This, in this case, is the angular difference. I hope we are understanding these diagrams because the diagrams are kind of in 3D, so you have to be good at imagining like what is happening inside the earth, within it, inside, right? So if you look at this from the top, if you look at this, if you have a top view, look at this. If you want to decipher it and you want to look from on top, you are going to be having something like this. That's for this diagram. You'll be having something like this. If you sum these two, that is your angular difference. Then for this one, you have to analyze it by looking at it from the side or from the front sef. If you analyze it, you'll be having something like this. If you sum these two, that is your angular difference. If you sum these two angles, that is your angular difference. If you sum these two angles from here, that is your angular difference. You have to learn how to know the view you have to look from to understand the 3D picture. If you look from on top, you understand this one. If you look from the side or from the front sef, you understand this one. Are you following? Yes, I know you are following. If you're confused in any part, just move back a few seconds and try and keep up. Don't just be moving in the video without understanding what you're watching. Okay. Okay, so these are three sets of questions. Number one is, what is the angular difference between this location and this location, E and F? What is the angular difference between E and F? Number two is, what is the angular difference between G and H? Number three is, what is the angular difference between A and B? All these are different locations. Let me say here, a cat is standing at E and a dog is standing at F. So what is the angular difference between these their two locations? These things are basically locations, they are not far-fetched. 30 degrees north, 45 degrees east is just basically denoting where something is. It's just denoting a location. Are we following? Let's move forward. Let's decipher the first one, E and F, right? Okay. So firstly, we draw the earth. So what is the angular difference between 30 degrees north, 45 degrees east, 25 degrees south, 45 degrees east? What is common between them? Firstly, let's draw everything that needs to be drawn. You have your polar axis, north, south, east, west. So 30 degrees north is somewhere here. Okay, it's more below because 30 degrees north is far from the top. So let's just keep it here so we'll be able to analyze the picture easily. Then we have 25 degrees south is somewhere here. Right? Okay. Okay, so this is 30 degrees north and 25 degrees south. These are the lines of latitude. I told you latitude is used to find locations at the north or the south. Now, what is the line of longitude? The line of longitude is 45 degrees east, not southeast. So it's going to be at the center, the perfect center, 45 degrees. So these are the two locations. E is here. E is 30 degrees north. E is here. F is 25 degrees south. F is here. Right? So what is the angular difference between them? Firstly, you spot that this is the center of the earth. This is the center of the earth. This is the center of the earth, and let's just draw the radius of the earth somewhere here. It connects like this. This is the radius of the earth. Okay, now we are going to measure from here to here. Then we'll measure from here to the second location. Now, this is basically that 30 degrees north. This is 30 degrees. This angle here is 30 degrees. This one is 25 degrees. This is the 30 degrees. This is 25 degrees. This is 30, this is 25. Are we following? If you look at it from a 2D view, let me say you move the earth this way, you shifted the earth like this and looked at it, and you were looking at it as a circle, you'll be seeing something like this. (30 and 25). Are we following? 30 and 25. So what is the angular difference? The angular difference is 30 plus 25. The angular difference is 30 plus 25. 30 plus 25. So the angular difference is what? 55. Are we following? That is for the first example. I hope you're writing. Okay, let's move to the second one. For the second one, we have 70 degrees north and 35 degrees west, and 40 degrees north and 35 degrees west. So we are going to have this. This is the center of the earth. Okay, this is the polar axis. This is north, south, east, and west. Right? So now we have 70 degrees north and 40 degrees north. It means both locations are the upper part of the world. Both locations are the upper part of the world. So 70 degrees north is going to be somewhere here. Right? And then 40 degrees north is going to be somewhere here. Are we following? This is the center of the universe, of the world, and then this is the radius of the earth. Okay, so now we have to check. Okay, then what was the longitude? 35 degrees west. 35 degrees west. So north, south, east, west. 35 degrees west. This is 35 degrees west. Okay, so if this is 35 degrees west, the two locations are here. This is G, and this is H. This is G and this is H. Now, what is the angular difference between G and H? Now see. When you have the same, okay, when you are analyzing with the same longitude, that is 35 degrees west, 35 degrees west, and then you have their latitudes being on the same part of the earth, and you have their latitudes being at the same part of the earth, that's you now have 70 degrees north, 40 degrees north. Usually, let me say, they'll say 70 degrees north, 40 degrees south, but this time around both of them are on the same part of the earth, so the angular difference this time will be subtraction. You will not add 70 to 40, you will subtract them from each other because they coincide with each other. Are we following? This is what you have. Firstly, you connect this one. If you connect this one, this is the 40, and if you connect this one, this is 70. So you have something like this. This is 40, but everything is 70. But everything is 70, right? Only this one is 40, but everything is 70, right? So what do you have? Because of two of them, both locations were in the north when they had the same longitude, you are going to subtract. So the angular difference is going to be 70 minus 40. Which is what? 30 degrees. That is the angular difference for this question. So now, the final one is this for A and B. You are having, we'll draw the same thing again, center of the earth, polar axis, right? North, south, east, west. Okay, and then we are having 40 degrees north is common. So 40 degrees north will be somewhere here, right? If we have 40 degrees north there, we have 35 degrees west, 50 degrees east. 35 degrees west, 50 degrees east. So we are having this 35 degrees west. Then 50 degrees east. Right? So what is the angular difference? The angular difference is, since these are the two locations, you're having something from here. What is that angle? So if you look from on top of the earth, you'll be seeing something like this. $35 degrees and 50. So that's what you're going to be having. This one is going to be addition again. The angular difference is 35 plus 50, which is what? 85. This is the angular difference. This is the angular difference for this question. So now we know how to find our angular differences. Our next topic is finding distances along big circles. We'll be back soon. Okay, so watch this now. We have this. Then our first position, okay, firstly, you already know what we do. We draw our equator, we draw our polar axis. Then let's say this is our line of longitude. Then these are our two positions. Two latitudes. So watch. This is the first position. This is the second position. What is the distance along the great circle? The distance along the great circle. So we always use our equator as reference for great circles. This is the distance from the great circle to location A. This is the distance from the great circle to location B. So if you realize this now, these lines that are protruding out are actually the radius of the earth. It's still the same radius of the earth. See, if this is the earth and I cut from here, or I cut from here, I cut from here, I cut from here, they are all the same thing. They are all still the same radius of the earth. They are all still the same radius of the earth. They are all still the same radius of the earth. So this is what you have actually. This is the distance along the great circle, taking here as reference, which we will always be doing, taking here as reference. This is the distance along the great circle D. Now, remember, from circles, if you still remember how to solve circles, what did we say? What did we say is the length of an arc? Because if you notice, this distance is the length of an arc. What did we say is the length of an arc? We said the length of an arc is theta over 360 times 2 pi r. In this case, what is our r? R is basically that radius of the earth. R is the radius of the earth. So we have the length of the arc is theta, whatever angle we have here. So now, what is that angle? What is that angle? The angular difference. The angular difference is the theta we have here. Is theta over 360 times what? 2 pi. Don't go put small arrow, capital R, because this is the radius of the earth. This is the major formula in this topic. This is the major formula. Very, very simple topic. If you know this and you know how to find your angular difference, you already know the radius of the earth is always 6,400 kilometers. If that's the case, you are good to go. Now, see, in your school, they might say the radius of the earth is maybe 6,371 kilometers or so. It can vary. Most times in the question, they will give you what they want you to use as the radius of the circle. So this is what we are going to be using. This is what we are going to be using. This is what we are going to be using to be doing all our calculations. Let's go. Okay, so we are gradually coming to the end of this topic, but not quite yet. We still have to understand how to use this to find the actual distance between 2 points on the earth, because now we know how to find the angular difference between them. But now, can we implement it into actually knowing the distance between them? You know, you can't just use a tape like I said before. The earth is curved. The earth is curved. So if you want to find the distance between 2 points, it's basically like solving the length of an arc, right? You have to find the length of the arc that connects those 2 points on the surface of the earth. So let's go. Firstly, we have A and B. Please, at this point, we are going to be speeding because I don't want this video to be too long. I'm assuming you already know how we are going to find these two locations on the surface of the earth. We have this, right? Then we have 30 degrees north. This is the center of the earth. Then we have 30 degrees south as well. South, 30 degrees north, and we have 40 degrees west. Firstly, this is our polar axis, north, south, east, west. These are 40 degrees west. Okay, so how do we find the angular difference? I already told you we are going to be using the center of the earth as our reference for big circles, because we are going to be finding distance along the big circle. So we are using the center of the earth as our reference, right? So this, we have this, and we have this. These are the 2 points, right? This is point 1, this is point 2. So we just stretched from here to here, from here to here. So you already know these two lengths are basically radius of the earth. These two lengths are radius of the earth, right? So this is what we have. We have something like this. If you look at it from a proper angle, we are looking for D here. We are looking for D. This is the radius of the earth, this is the radius of the earth. And what are the two angles? I already told you. Hold on. Okay. This this is what? This is 30 degrees north and this is 30 degrees south. So 30 plus 30 is what? 60. So everything is 60, right? Our angular difference is 60. Our angular difference is 60. So what we have is theta over 360 times 2 pi r is our angular difference, right? So our angular difference is 60 over 360 times 2 times 22 over 7 times, this is our r, this is the radius of the earth, 6,400 times 6,400. I have to clear some space so we'll be able to, there is minimal space on this board. So we have 60 6,702 is our distance between those two locations. Don't forget to add your SI unit, which is kilometers. 6,702 kilometers. That is 60 over 360 times 2 pi r, which is 2 times 22 over 7 times 6,400, give us 6,702 kilometers. Let's move forward. Second one, we have this. I told you, you should already understand this by now. If you're looking at this, what is our latitude? 0 degrees. They say 0 degrees south, but it doesn't matter. If they say north or south and they say 0 degrees, they just mean flat center. They just mean flat center, flat center, flat center. So the location is somewhere around this flat center, right? So 20 degrees west, 50 degrees east. Don't forget north, south, east, west, polar axis, 20 degrees west, 50 degrees east. So this is our center of the earth. We connect it and find the angular difference. So this place now is 20 degrees west, right? So this is 20 degrees, 20. This place now is 50 degrees east, right? So this is 50 degrees east. So 20 plus 50 is our angular difference. They do not intersect each other. They are not on the same side. So 20 plus 50 is 70. So don't forget it over 360 times 2 pi r, right? So this is our angular difference. This theta is our angular difference. 20 plus 50 is what? 70. Our angular difference is 70 over 360 times 2 times 22 over 7 times 6,400. What is your answer? So our final answer is 7,822 kilometers approximately. This is our final answer, 7,822 kilometers. Now let's move to the next question. Are you seeing how simple this topic is? Now, (40 degrees north), 10 degrees north, 15 degrees east, 15 degrees east. Don't forget your polar axis. North, south, east, west. So 15 degrees east is our longitude. We have something like this. Okay, so this is our 15 degrees east line. So connect it, connect it, connect it. We are having this. We are having this. So they both intersect, right? Since they both intersect at north, both locations, both our latitudes intersect at north. They both intersect at north. So we'll be having something like this. They both intersect at north. So our diagram will be looking something like this. 10, here will be 10, and then everything will be 40. So 10, 40. So what is the angular difference? 40 minus 10 is our theta. That is the angular difference. 40 minus 10 is our angular difference. So let us find, which is 30, right? Let me just leave it there so you keep seeing it. 40 minus 10, which is equal to 30, is the angular difference. So theta over 360 times 2 pi r is 30 over 360 times 2 times 22 over 7 times 6,400. So what is the answer? Our answer is 3,352.4 kilometers approximately. This is your final answer. And we now know how to calculate distances along great circles. We now know how to calculate distances along great circles. This has been simple so far, right? I know it is. I'm a great teacher. Okay, guys, we are going to be continuing with distance along small circles. So now, if you remember, when we are solving for distance along great circles, we are basically doing this. Let me say this is one longitude, this is another longitude. You're finding this distance from here to here along this circle. That's along this circle. You're finding the distance from here to here along this great circle, which is the center of the earth. It could also go like this. These are two longitudes, sorry, two latitudes. Then this is a great circle that basically passes through the largest side of the sphere as well, and you're finding distances from here to here along this great circle as well. Then this passes through the back. I hope you guys know that since we've been drawing these broken lines, those are the parts that pass through the back of the earth. I hope you know. Now I'm just saying it. I hope you guys have known since. So basically, this is also a distance along the great circle because this is also a great circle, right? Okay. But now, what about small circles? What about distances along small circles? Now, this is a small circle. We want to find the distance along small circles. You have this. You have the great circle that we mostly use, which is the equator. Then you have the polar axis, right? You have your north, you have your south, you have your east, and you have your west. Now, this is the small circle. Now, this time around, instead of using this great circle as a reference, I want to find the distance from here to here on my small circle. I don't want to find it from here to here. I want to find it from here to here on the small circle. On the small circle, right? I want to find it on the small circle. So what do I do? How do I know that distance? Firstly, let's draw this line of radius of the earth to this place. Some of you might just want to know how to solve it because your exam is tomorrow. If that's what you want to do, skip this part as well to where the calculation is going to be. If you want to move straight to the calculation, you can skip this. I'm proving how we got the formula. I'm proving how we got the formula. Now we have theta here. We have an angle theta here. This is basically that angle that is usually common between the two locations. This is that angle that is usually common between the two locations. So we have that angle theta here. So let's look at this. Let's look at this. We want to find the distance between 2 points on this small circle, right? So now mind you, this is R, this is R. My marker. This is R, small r this time around, which is the radius of the small circle. Notice that is the radius of the small circle, right? If you look from on top, you're having something like this. If you look from on top, you're having something like this for the small circle, right? Then if you look from the on top, you're having something like this for the big circle. So this is the radius r. Now let us look at it from the side view. Let us look at it from the side view. In fact, from the front view. Let us look at it from the front view. From the front view, we are having this. Let's analyze this. We are having this. Right? Is that not what you're seeing? Are you seeing what I'm seeing? Are you seeing what I'm seeing? Are you seeing what I'm seeing? Then this place is theta, right? If this place is theta, like, can you still remember your circle geometry? If this place is theta, or even it's not even circle geometry, just basic how we analyze shapes, you still remember that alternate angles are equal. Alternate angles are equal. So this is an alternate angle to this. So you have theta here as well, right? You have theta here as well. You have theta here as well. So what do we do at this point? We want to find R. We want to find R. We want to find R, and we have this triangle. This small r now is the radius of the small circle, right? And we have big R here. So how do we analyze this? If you're looking at this properly, this is opposite to this angle. This is adjacent. Small r is adjacent to this angle, and the radius of the head, that's the big radius, is the hypotenuse, is the longest side, right? So now, what so toi? Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is toi, opposite over adjacent, right? So now, what connects adjacent and hypotenuse? What connects adjacent and hypotenuse? You're right, cos. Cos connects adjacent and hypotenuse. So we have cos theta is equal to adjacent r over hypotenuse r. So what is small letter r? What is your small letter r? What is your small letter r? Yes, you have it. R cos theta. So there you have it. You have your small letter r is r cos theta. You have your small letter r is what? R cos theta. Now, if you want to implement it into the main formula, which is theta over 360 times 2 pi r for great circles, if you want to implement it into this formula for great circles, this becomes alpha over 360. Alpha over 360. Alpha is what we are now going to call the angular difference. Alpha becomes the angular difference. Note this, write this down. Alpha becomes the angular difference. Alpha becomes your angular difference times 2 pi. Now, instead of writing r, we are now going to write r cos theta. R cos theta. What is theta? What is theta? Write this down as well. Theta is the common angle. Theta is the common angle. So we are going to have r cos theta. This is the formula for small circles. Alpha over 360 times 2 pi r cos theta. When we start using it to solve, you are going to understand it even further. When we start using it to solve, you are going to understand even further. Let's go. Okay, so now we are about to continue finding our distances along the small circles. We are about to start finding our distances along the small circles. So I'm about to give you, let me say 5 seconds. Please copy this. Copy this. Copy what you are seeing. Copy what you are seeing. I'm about to claim part of it so that we can have space to calculate. Okay. Pause and claim and copy. So we are about to find our distances along the small circle. What was our formula for distance along the small circle? Distance along the small circle is alpha over 360 times 2 pi r cos theta, where theta is 28 here, right? 28 will be your theta because they are the same. 28 is your reference, so 28 is your theta. Then angular difference 60 degrees east, 20 degrees east. Let's solve the first one. What will be our angular difference? We don't have to draw diagrams again because of 60 degrees east and 20 degrees east are both at the east side. They are both at the east side. Therefore, your angular difference will be 60 minus 20. So your angular difference for question 1 is 60 minus 20, which is equal to 40 degrees. So the distance along the small circle for question 1 is 40 all over 360 times 2 times 22 over 7 times, what is your r? 6,400, right? Times cos what? Cos 28. Cos 28. That is going to be your answer. So your final answer, the distance along the small circle is going to be 3,946.6 kilometers. This is your final answer. This is your final answer for question 1. Now let's go to question 2. Please, if you're solving this in your class, make sure you're showing full working for your exam, sorry. Okay. For question 2, observing what is common here is 56 degrees, right? So 56 degrees is more like our reference. Okay, it's more like our theta. 56 degrees is our theta. So what is our angular difference? Our angular difference is 43 degrees west, 73 degrees east. So our angular difference alpha is equal to 43 plus 17, because west and east are on separate sides of the globe, right? West and east are on separate sides of the globe. It's not like east and east. So what is going to be your answer? You're going to have 60 as your angular difference. So you're going to have 60 over 360 times 2 times 22 over 7 times 6,400 cos what? Cos 56. That is what you're going to have. So let's find that. So your answer is going to be 3,749.255 kilometers. You can approximate that to just 25 kilometers. So that is basically it for this topic. That is it for longitude and latitude. We found how to, understand the globe, how to find our angular differences, how to find distances along big circles, how to find distances now along small circles. So this is it for this topic. Now we'll be taking one advanced question, and we'll call it a day. We'll call it, that's the end of this topic. Let's go. Okay, so we've come to the end of this topic, and we are going to be concluding with two very interesting questions to make sure that the topic sinks in. We are going to be going with practical questions to make sure that it sinks into you. Now, let's go. What is the first question? I'll show this on your screen. I can't fit the entire question into the board, so I'll show it on your screen while I write from here. The question is this. Pause and write as fast as you can. Just pause and write. The question is this. Bakwai and Dekwa are two towns in Africa on latitude 12 degrees north. Bakwa and Dekwa, B and D, are on latitude 12 degrees north, right? So you have this. Our center of the earth, or our equator, our polar axis, our north, our south, our east, our west. So both of them are 12 degrees north, right? Both of them are 12 degrees north. Okay, so they said Bakwai is to the east of Dekwa. Okay, so Bakwai is somewhere here. Bakwai is somewhere there. And Dekwa, okay, and on longitude 40 degrees east. So Bakwai, that's B, is here, 40 degrees east. B is on 40 degrees east. So what is the question? Assuming the earth is a sphere of 6,400 kilometers. Assuming the earth is a sphere of 6,400 kilometers and pi is 22/7. Calculate to trace significance figures. What should we calculate? The radius of their parallel of latitude. Now, what did I tell you is the formula for radius of parallel of latitude? R cos theta. That is radius of the earth cos theta. R cos theta. So R here is 6,400, right? That's the radius of the earth is 6,400 cos what? What is the common angle between two of them, or what is their reference? What is their reference? What is their reference circle? 12 degrees north. 12 degrees north. See, Bakwai is here. Dekwai will probably be somewhere here. Dekwai will be somewhere here, but they both share the same latitude, which is 12 degrees north. So 12 degrees north is their theta, right? 12 degrees north is their theta. So the answer is 6,400 cos 12. 6,400 cos 12. What do we have there? We have 6,260.145 kilometers. We are asked to trace significant figures, right? So that is it. That is it, 6,260.145 kilometers. That is our answer. Then they now say the longitude of Dekwa, if the distance between them along their parallel of latitude is 2,840 kilometers. Now note this, since they said this one is 40 degrees east and it's to the east of Dekwa, it means Dekwa is somewhere here. Dekwa is somewhere here. Dekwa is somewhere here. So what is this point? What is this point? How many degrees north, south, east, west? How many degrees west is Dekwa? How many degrees west is Dekwa? So now remember, we have this formula. We have this formula. For when you're finding along the small circles, we have this formula, alpha over 360 times 2 pi r cos theta, right? So D is equal to, we are going to call this place, we are going to call this angle of west x. We are going to call it x. We are going to say x plus what? x plus 40 degrees. That is going to be the angular difference. We don't know the angle of the side at the west part, so we are going to call it 40 degrees. We are going to call it 40 degrees. X plus 40 all over 360 times 2 times 22 over 7 times r 6400 times cos what is the common cos 12. So that is going to be our answer. That is going to be our answer. But what did they say is d? They gave d already. They gave d as 2840. So we have 2840 over d is equal to x plus 40 all over 360 times, let's solve this other part. Let's solve this other part so we can be breaking it down for ourselves. We have 39,349.5. 39,349.5. Okay, we are going to cancel. We are going to cancel. Firstly, you already know you can move this one up here. When you move it up there, what do we have? 360 times 2840 is what? Let's go with this. All over 39,349.5 is equal to what? X plus 40. So what is going to be your answer there? Our answer is 25.98, which is basically 26. So our answer is what? Basically 26. So we have 26 is equal to x plus 40. So x is what? X is what? 40. Sorry, 26 minus 40. Minus 14. So because we got minus 14 in this case, since we got x to be minus 14, what does that mean? It means that it's not actually 14 degrees on the west. It is not 14 degrees on the west. It's actually inverse. It's inverse, therefore it is 14 degrees on the east. It is 14 degrees on the east. So this is x is 14 degrees east. X is what? 14 degrees east. So we can clean this. Our final diagram is going to be this. That y is somewhere here. 14 degrees east here. So this is the distance between dark y and back y. So that's it for this question. Thank you. Okay, for the final question, we need to rush through this one because it's already getting dark. So what were we given? This question will be shown on your screen as well. They said P latitude 60 degrees north and longitude 15 degrees east. That is the position P is on latitude 60 degrees north and 15 degrees east, right? So 60 degrees north and 15 degrees is north south. So this is P. This is P. Then Q. Where is Q? 60 degrees north, 48 degrees west. So Q is here. Okay, and so what were we told to do? And they said and R is 38 degrees south and then the longitude is 48 degrees west. Now see, we are going to hold on doing that one. We are going to hold on doing that one. But let me just represent it. Now this is 48 degrees west longitude, right? So then 38 degrees south is here. So this is where R is. This is where Q is. Okay, so what were we told to do? What were we told to do? What were we told to do? They said these three places are on the Earth's surface. Calculate to three significant figures the distance PQ measured along the latitude. PQ measured along the latitude, that is from here to here, not along the center of the earth, but along the latitude. That is what is from here to here. So this is how we are going to solve it. You are going to be solving using this. So PQ, saying PQ basically, PQ is basically the small r is equal to r cos theta. When they say along the latitude, anytime they say find distance along the latitude, they are just basically telling you find the distance along the small circle. So r is equal to r cos theta. You have r is equal to 6,400 cos what? What angle do they have in common? 60. 6,400 cos 60. That is 3,200. So we have our first part, kilometers. So our PQ, which is the distance along the latitude, is 3,200. Now, what is distance QR measured along the meridian? QR along the meridian. QR along the meridian is basically saying, what is the distance along the center of the earth? It's the same thing along distance along the great circle, right? So we are going to have this. For that one, we are going to have this. Theta over 360 times 2 pi r. Theta over 360 times 2 pi r, which is what? What is theta? What is theta here? They gave us 60 degrees north. For Q and R, we have 60 degrees north and 48 degrees west, right? And then 38 degrees south and 48 degrees west. So since north and south are on different parts of the earth, that's north is up, south is down. Therefore, we are going to have 60 plus 38 is our theta. Theta is equal to 60 plus 38. That is our angular difference is 60 plus 38, which is equal to 98. So we have QR is 98 over 360 times 2 times 22 over 7 times 6,400. So that is what we are going to have. So what is our QR? Let's call this R1 so that we can call QR R2, right? Okay. So QR is basically 10,951.11, or R2, you can say R2 is 10,951.1. Okay, so that is it. What is the next question? The next question then says, the time taken by an aircraft to cover the distance PQ and QR at an average speed of 85 kilometers per hour. Okay. What are we going to do about that? Let's clean here so we'll have enough space. So firstly, PQ is equal to 3,200 kilometers and QR is equal to 10,951.1 kilometers. If that is the case, time taken by an aircraft to move distance PQ and QR at speed. So distance is equal to the total distance the aircraft has to cover is what? 3,200 plus 951. This is what we have. So this is the distance. Okay, so what do you know about speed, distance, and time? We know that speed is equal to distance over time. So speed is equal to d over t. Since we are given our speed is 800 kilometers per hour and our distance is 14151 all over time, what is going to be our time? Our time is basically 14151. You are going to cross multiply all over 800. So what is our time? Our time is 17.69 hours. This is our time, 17.69 hours. 17.69 hours. So yes, thank you. This is the end of longitude and latitude. If you have any questions, you can drop in the comments, or you can even reach out to me. I'm going to drop my number so that you can reach out to me, ask your questions, and please like, follow, subscribe to get more videos or more content like this, more educational content, so we can learn and grow together. Thank you.